Let's see if you identified the correct pairs of similar shapes. O and R are similar, and we can see that because the base of O is 2 and the base of R is 4. And then if we compare their heights, the height of O is 1 and the height of R is 2. So we can see that there is a scale factor that relates the two of them. The scale factor from the little triangle to the big one, to get from 1 to 2 for the height, to get from 1 to 2, and to get from 2 to 4 for the base, you have to multiply by 2. So the scale factor between O and R is 2 if we think about going from the little triangle to the big triangle. If we go in the reverse order, the big triangle to the little triangle, the scale factor would be 1/2. There are two more pairs of similar shapes. R and S are also similar. And with this one, the scale factor is not quite as friendly. If we look at the base for R, its base is 4, and the base for S is 1, 2, 3, 4, 5, 6. And then if we compare the height of R is 2, and the height of S is 3. So we have to find the scale factor that relates them. And the scale factor is the number that we'd multiply this 4 by to get the 6 in the larger triangle. They're corresponding sides because they're the base in each. So we have to figure out what to multiply 4 by to get 6. And also that same number, when we multiply 2 by that number, we should also get 3. And so I know that from R to S, I have to have a scale factor that's bigger than 1, because we have to multiply 4 by something bigger than 1 to get a result of 6. So I know the scale factor is going to be bigger than 1, and I have to divide to find it. So I can take corresponding sides and do 6 divided by 4. And if I do 6 divided by 4 on a calculator or in my head, I get 1.5. And similarly, if we look at the heights in R and S, if I take the height of S, 3, and if I divide it by 2, I get 1.5 as well. So the scale factor to get from the little triangle to the big triangle is 1.5. Now, if I wanted to go in the opposite order, I just have to divide in the opposite order. So if I want to go from big to little, I know that my scale factor has to be something smaller than 1. So I can divide in the other order, and I could do 4 divided by 6, and 4 divided by 6 gives me 0.6 repeating, or about 0.667. And if I also were to do 2 divided by 3, and divide the shorter height by the longer height, the height in R divided by the height in S, I also get 0.6 repeating, or about 0.667. So those are both scale factors that relate these two triangles. We'd use the scale factor of 1.5 to get from the little triangle to the big triangle, and we'd use the scale factor of 0.667 to get from the big triangle to the little triangle. The last pair of similar triangles would be O and S, and that work again is pretty straightforward. O has a base of 2. S has a base of 1, 2, 3, 4, 5, 6. That's right. And we can compare the heights as well. Remember, O has a height of 1. S has a height of 3. And from here, we've definitely worked with triangles and shapes like these before with kind of nice scale factors. The scale factor from O to S is 3, because we have to multiply 2 by 3 to get 6, or to multiply 1 by 3 to get 3. And so we know that that scale factor would be 3. And then the scale factor, if we go in the reverse order, from big to little, that scale factor is going to be 1/3. And here's one example of writing a rule to relate two similar shapes. So if we look back maybe at going from R to S, if we wanted to write a rule to relate going from R to S, we could think of R as our starting figure, and we could call that xy. And then if we want to go to S, we found the scale factor from R to S was 1.5. So if we want to make triangle R represented by x comma y 1.5 times bigger, we'd have to multiply both the x and the y by 1.5.